Welcome back. Now we're almost done with this section where we have basic functionality for picking up weapons, putting the weapons away, taking them back out. I think there's a couple of finishing touches we can add to this by the way of sounds. So I'd like to play a sound when we put the weapon away, when we pull the weapon back out, and also when we pick up a weapon for the first time. So let's go about doing that. Now the easiest thing we can do is go to our Equip montage and add a play sound notify. And I'd like to do this right about the same time we release our hand on the weapon when equipping. So I'm going to add another notified track, and I'm going to call this Equip Sound and add a play sound notify. So add notify, play sound. I'm going to select that, and I think a pretty good sound for this would be our pouch sound effect, which we called pouch heavy. I'm going to stick that right there, maybe play it just before we attach, and in the unequip, right here for disarm, I'm going to play the same sound effect. So I'm going to right click on the pouch heavy, copy that, and right click over here and paste it. And now we can go ahead and play test this and see how it sounds and feels. So I'm going to put the weapon away. And that looks pretty good, sounds pretty good. I'm going to pull it back out. And that sounds great. So mission accomplished there. Now, when I pick it up for the first time, I'd like to play a sort of sword kind of sound. Now, for that, we need a sword shink kind of sound. Now, if you don't have one or don't know where to get one, you can go to the GitHub page for this. The link will be in the resources, and right here in the Downloads Sounds folder where we got our whoosh, we have blade1.wave, and if we download that, you can either click download or view raw, either one will download this wave. And if we go ahead and show it in the folder for the downloads, it's called Downloads Sounds Blade 1. And of course, we could rename this just to Blade 1 or even just Shink, because it's kind of just a shinking sound. I'm going to call it Shink. And we can take this Shink sound and get it into our project. So here's my / project. I can go into my assets, sounds folder, and I can simply move this Shink sound straight into it. And now I know where it is. I can import it into my project. So back into my project, in my content folder, I have my audio folder. There's my whoosh sound cue that we ended up not using because we used meta sounds, and there's our whoosh wave. Now I can import my new sound by clicking import and going to my assets sounds and get Shink and import that in there, and I can create either a sound cue or a meta sound. And since this is Unreal Engine 5, I'd like to make a meta sound. So I can go into meta sounds, right click, and make a new one by going to sounds and meta sound source. And I'm going to call this SFX_Shink. Now this is pretty straightforward. We know how to create these. In fact, if you forget, you can simply open one of the other meta sounds like whoosh and remind yourself how this is made. So we can go back and forth between these two for reference. Now the first thing we need is an input, so I'm going to go to Shink, add an input. I'm going to call this input Shink, and I'm going to change its type to wave asset. And for the default value, I can simply use my Shink sound wave. So here it is. I'm going to click it and drag it into Shink and drop it onto the default there. Now looking at whoosh, I see that I have the input for whoosh. For Shink, I'm going to do the same thing. I'm going to bring it in, and we need a wave player. So I can drag off of Shink and type wave player and get that, and hook my on play straight up to play. Now, if we want a bit of variation, we can have random floats for the pitch shift and for the volume. So let's go ahead and do that. I'm going to get a random float, and I can take my on play and hook it up to the next and give this a min and max. Now, whoosh has a min and max of 0 and 1. I'm going to go for 0.5 and 1.2 and hook this up to the pitch shift. And I'll hook my on finished into on finished and out left straight into out mono and see how this sounds. So not too much variation there. I might go to -1 for the min. And that might be too little, so maybe -0.25. So this can take a bit of tweaking. I'm pretty happy with that. And for my volume multiplier, I'll just create a random float. Hook my onPlay into next. And we'll multiply this by out left. So I'll get a multiply audio by float, hook that in, and play test this. And sometimes it's a little quiet, so I'm going to go from 0.5 to 1. I think that's good. Okay, so now that I have a sound effects that goes shink, I can play this when I equip a weapon. Now, when we equip a weapon, we're essentially using our E key pressed. So scrolling up to E key pressed, here's our function. It's already starting to get kind of big, so refactoring may be in order here. But if our overlapping weapon is not null, then we equip the weapon, which means we can play a sound. Now, I'd like this sound to be unique to the weapon. If a weapon is a sword, we could play the shink sound, but if it's a hammer or a staff, we might want different sounds. So the sound should really be unique to the weapon, and I think we can play that in the weapon's equip function. So here's the weapon.cpp file, here's equip, we're calling attach mesh to socket and setting the item state. Here would be a good place to play a sound. So let's do that. We'll first need a sound, which means we have to go to weapon.h, and we'll add a variable for this sound. I'll add a private section, so this can be a private variable. And for this, I'd like to use one of the parent classes of our metasound type. So metasound actually derives from a C++ class, which I can search for. It's uMetaSound source. And uMetaSound source, if we click on it, looks like I clicked on this particular function on uMetaSound source, but up here we have links that take us back out to the hierarchy. I can click on uMetaSound source here, and I see that it's based on these classes. Its first parent is uSoundWave procedural. Up higher we have uSoundWave, and higher than that we have uSoundBase. And SoundQ, by the way, is based on uSoundBase as well. So if I choose uSoundBase, then later if we decide to create a SoundQ, we can use a SoundQ to set our variable in Blueprints. So I'm going to use uSoundBase. So right here, I'll make a new variable of type uSoundBase. It's going to be a pointer, and we're going to call this equipSound. And I'd like to be able to set this from the default blueprint, but also from any instance in the world. So we'll give it a U property, and we'll make this edit anywhere. And if we like, we can give it a category. I'm going to give it the category weapon properties. And I can forward declare the uSoundBase type right here at the top. So we'll say class uSoundBase, and now we don't need to include the header for SoundBase. Now, if we set this in Blueprints, we can then play it in the weapon class. And to play a sound, we need gameplay statics. Let's hop back over to the documentation page. And I'm going to search here for play sound at location. And here it is. It's a gameplay statics function. So we see that we need gameplay statics, which here's the include for it, Kismet/gameplay statics. And we see that it takes a number of parameters, but we will soon see that many of these have default values and we can omit them. But this page tells us what all those input parameters do, so it's really useful. So I'm going to copy the include and paste it here in weapon.cpp so we can use gameplay statics. And right here in equip, I want to play that equip sound, which means I need to make sure that it's actually set. If we forget to set it in Blueprints, then it'll be a null pointer. So I'm going to check if equip sound first, and then I'll access gameplay statics. So we'll say gameplay statics play sound at location. And the function does what it says. It plays a sound at the location, which means we need to provide a location. Now, the first input parameter is a world context object. And gameplay statics functions are static functions. They belong to the class called UGameplayStatics, but because they're static functions, they don't actually require an instance of the GameplayStatics class to exist in the world. GameplayStatics is not something that you just create an object of to call functions on it. You call the static functions on it, and those static functions just exist. We don't need to search for and find a GameplayStatics object. Instead, we just access its static functions. Now, because these are static functions and we're not calling a function that exists on any particular object, this function needs to know the world that we're in. And it does that often by taking in a world context object, basically a pointer to any object in our world. And it can take that object and see what world it's in, essentially by following its owner. And if its owner is the world, then the function knows what world we're in. If its owner is not the world, it'll trace that object's owner, and then the owner's owner, and then the owner's owner until it gets to the world that we're in. So a world context object can literally be any object that exists in our world. And usually for these functions, we pass in this because this is a pointer to the object of this class that we're in that's calling this function. And that does exist in our world. So this is an easy way to satisfy that input. Now next we have a uSound base called sound. That's our equip sound that we're going to pass in. And the next input parameter is an F vector called location. Well, we can get the location of our weapon. So we can call getActorLocation, and that will satisfy the location. And next we have some additional optional parameters such as a volume multiplier, a pitch multiplier, a start time, attenuation settings, how do we want this sound to fall off the farther we get from it, and so on. And those all have default values, so we can skip them. And by the way, if you were curious how to add default values to a function, we can right-click on this function and go to its declaration by clicking Go to Declaration. And if we look at the input parameters, we'll see that volume multiplier says equals 1 here. That means if we don't pass in a value for this, it'll be set to 1 by default. And pitch multiplier is 1, start time is 0, and so on. So functions that have default values don't require us to pass values in for those input parameters. All right, so now that we're playing a sound at location when we equip a function, we can test this out by pressing Save All and hopping back into the editor and doing a quick hot reload. So once we've finished that, we can go ahead and playtest. But before we playtest, remember, we have to set that sound in the weapon blueprint. That means we need to go to our blueprints folder into Items, Weapons, and Open BP Weapon. And we'll select BP Weapon Self and look for the Weapon Properties category that we created. So we can search for it. Here's Weapon Properties. There's Equip Sound. And we can choose our shink sound. So I'm going to find that sound effect, shink, not the sound wave, but our meta sound, and compile and save that. And now if we press play and pick up a weapon, then we play that sound, and that sounds awesome. And we put it away, it makes a sound. We pull it out, we make a sound. We swing it, we make a sound. So sounds can make a really big difference in our game as we're seeing. Now, if I press E again, I play the sound again. And that's if I swing the sword and then press E. And that's not ideal. We don't want that to happen. So let's debug this. Let's find out why that's happening. We know that we're calling the equip function for some reason. And it happens after we swing the sword. So let's go to /character and take a look at attack. Now we see that we're checking to see if we can attack. We're playing the attack montage. We know that the montage has a notify, and that notify results in calling attack end, which puts our action state back to unoccupied. And if we press the E key, we're getting our E key pressed function called, which is checking to see if our overlapping item can cast to a weapon. Now we know that we're setting overlapping item to null pointer. So what's going on? Are we setting overlapping item back again? It's possible that we could be doing that. And because overlapping item is right here in visible instance only, we can see if that overlapping item is being set again. Let's press play, and before we grab a weapon, I'm going to hit Shift F1, and in the outliner, I'm going to search for slash and select slash character and search the details panel for overlapping. And here's my overlapping item. Now, if I go up to the weapon, overlapping item is set to BP weapon. And if I press E, it's set to none. But what happens if we start running around and swinging the sword? Look at that. It's all of a sudden set back to BP weapon. And that is not good. That's not something we want to happen. And I suspect it's because that overlap sphere is overlapping again with our character's capsule. Let's go ahead and hit tilde and type show collision. And we can see that sphere. And if we attack, it does look like the sphere ends and begins overlap all over again. Yeah, overlapping item goes to none and is set back to BP weapon. In other words, we're getting those overlap events happening again, and that's not what we want. We want to prevent those overlap events from happening once the weapon is equipped. So we can take care of that pretty easily by going to weapon.cpp, and once we equip the weapon, we can stop those overlap events from working. Essentially, what we want to do is get our overlap sphere and disable collision for it. And we know that we can set the collision presets from here in the blueprint. If we go to BP weapon and select the sphere and go to collision, here's the collision presets, and we see that collision enabled is set to query only. If it were set to no collision, well, then we wouldn't have any overlap events. So we can set that to no collision from our weapon class. And we'll do that right here in equip. Now that sphere is called, if we go to item.h, we can find it. It's called sphere and it's private. And now we want to access it and change properties on it from a child class. We want to do it from the weapon class. So now we have a reason to move it into the protected section. So we're going to do that. We're going to go ahead and take our sphere variable and simply highlight it and drag it into the protected section. And now we should be able to access it from the weapon class in the equip function. And that's what we're going to do. We're going to check first to see if it's valid, so if sphere, and if it is valid, then we can disable its collision. Now this does mean we need to include the header file for sphere, which is in components/sphere component.h, and you can always find that out by searching for uSphere component in Unreal Engine documentation. And now that we have the sphere, let's disable collision for it by taking sphere, and the function we're after is set collision enabled. This allows us to set the collision enabled, and its type is eCollision enabled. So if we type eCollision enabled and type the 2 colons, here are those collision enabled options. We can choose no collision here. So if we do that and save all, then hopping back into the editor, we can do a hot reload. And I'm going to go ahead and save all here before I do that and click hot reload. And with a successful hot reload, we can now test out our new fix. And in the outliner, I still have slash in the search bar. I'm going to select slash character, and I'm going to search for overlapping and take a look at overlapping item and make sure that that stays none after we equip the weapon. So it's set to BP weapon. If I press E, it's set to none, and if I attack, it never gets set again. So we don't get that bug where we're attempting to equip another weapon. So if I press E, it goes straight to the back, press E again, it comes out, I swing, I attack, I press E, everything is looking great. Perfect. Excellent job. So this is looking really good. We've done some polish up on the mechanics that we have so far, and everything's looking great. For now, we've got some good progress, and we're ready to jump into actually hitting things with our sword and causing damage and killing things. It's going to be amazing. So great job so far. I'll see you in the next video.